Hello, welcome to the first podcast here from Arch Reactor. We're going to be talking about 3D printing, digital fabrication, just a little bit of everything. My name is Scott Rocca.
Brian.
I'm going to go by Basilisk or Bass because there's too many Ryans in the world.
So just a little bit of background information about us. We all come from a little bit different background. We have a ton of different experience between the three of us. Personally, I've got a background in technical theater, which kind of helped me with a bit of engineering stuff on the fly. I've gone through MIT's Fab Academy program out in Providence, Rhode Island, and I've been playing around with 3D printing and all this other kind of crazy stuff for probably about 4 or 5 years now. But Ryan, what about you?
Basically, I just had a background in fabrication and basic stuff. Just woodworking, metalworking, really simple stuff.
Currently, we are using his mic stand that we are using for the camera's stand instead. It's pretty good.
Yeah.
You can't see it.
Not everything is what you make it, right?
Yeah.
Anyway, I've been hanging out with these guys for the last couple of years, and just being around 3D printers constantly has changed your perspective a lot. So that's usually why I'm here.
I dropped out of mechanical engineering school. I failed a lot on different things. I'm still working on getting a couple of my projects going. After I get my printer going and some other things running, I'm going to work on my drone and hopefully move it into place and start working on aquaponics. That's the current plan. But yeah, that's what I'm going for and currently doing.
I know one of my big projects right now is I've got over the road case on the side that you can't really see. I have my gigantic 3D printer called El Monstro. It's got a 4.5-foot build volume, and the machine itself is going to be a bit bigger than that itself. But enough of our little kind of tiny projects. This is our first podcast. We're really glad for everybody who's out there joining us and watching. As you can see, we're in the hackerspace. No hackerspace is clean. If it is clean, it's shut down.
Nothing's happening in
We're simply very down.
Well, you know, let a lot of magic smoke out in that case. But we're here. We're doing our first podcast. We're just kind of seeing how things go. And one of the first things that we wanted to talk about was something that was proposed on Hackaday. And that is the Automated Build Platform Challenge. Now, we talked about this a little bit before the podcast, and we all kind of have different ideas and theories on how it would work.
I have had one. I had one of the original MakerBot Cupcake automated build platforms.
Yeah.
And it worked awesomely for a week. And then it broke, and then it was sucky, and I couldn't get it working again really well.
Yeah. It belongs in a museum.
Oh,
Yeah. It's a museum piece. But that's one of the things that even MakerBot said that's the reason that they didn't continue the production of them, is because that it wasn't a reliable means of having an automated build platform. They patented the ever-living hell out of it, but they said, well, it's not very reliable.
Did they patent it?
They did.
Ooh.
Yeah.
The mechanic and the idea.
And now,
Now, is it Stratus?
Strataxis.
Is it Stratus or 3D Systems? I can never remember. I
I
think
think
it's
it's
Stratus.
It's
Yeah.
Stratus.
Stratus now owns MakerBot, which means that
They own the
I
patent.
think they own the patent as well, yeah.
And they have no
So
plans.
that
to
could be
manufacture.
interesting.
Yeah, so there's no plans of manufacture with that. So that means that if you come up with a different mechanical method of automatically taking a build off of the build platform, then you might have a profitable idea. Especially when you look at bot farms, you're going to have a print tender, so somebody who's just going around and making sure that nothing fails horribly. But then you need a reliable method of getting things off. One of the kind of joking methods that I suggested was having a robotic arm with a spatula, just kind of going in and flipping prints off. But there was also the idea of actually having a conveyor belt that would come into the chamber that everything's built inside of, and I know chamber's patented.
That should be coming out fairly soon, though, that patent.
But it comes into the chamber, does an auto bed leveling system, does the print, then that belt will move along, print cools elsewhere while the next print begins. But didn't you have another method of going about it?
Well, just looking at moving floor ideas is a lot of them are made on the idea that you have slats that actually move around in a conveyor style. But since you all have it leveled already, whenever the slats come back around and due to correct tension, they all come back level. Which is important when you're trying to get a movable floor that you can use for VR, because if you don't have it come back to level, you'll just disorient whoever's using it. So if you can adapt that.
I will say, though, I think one of the biggest advantages now is that you don't necessarily need a raft. Where, for those who aren't familiar with what a raft is, looks like we're having some technical issues, but feel free to keep listening. For those who don't know, a raft, when you're talking about 3D printing, you'll have a layer that prints first, and then everything that prints on top of it, so that it helps to secure your print to the bed, so that you don't have any warping issues and things just start to bow up on the sides and the print releases too early. So because we don't have those anymore, or we don't have as many of them.
We don't really use them anymore.
Yeah, exactly.
There's brimming and mouse ears and all sorts of
there's all kinds of other methods now. So because of that, you don't necessarily need those, which would make the process of an automated build platform a lot easier to use and implement. But yeah, that's the one thing that I really see as being an advantage now.
Well, if you have a moving slat, I feel it becomes easier to pop off.
Yeah. Because
you're not dealing with like a peeling method.
Yeah.
So it would just kind of pop off the things.
The one thing though with doing the raft on there though is that you don't necessarily have to do a leveling system,
right? Because
the raft will act as your leveling.
It's sacrificial.
Yeah.
Sacrificial leveling.
Exactly. So by doing that, then your prints will always come out consistently. Whereas otherwise, you have to go with the delta pop method, and you actually have to have a way of leveling out your bed.
But I think that's a fine thing to do if you have a delta bot and you have it. If you have something that's going to stay fairly flat, and you have the delta bot go, oh, click, 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 click. Okay, I know it's flat-ish here, and then it adjusts the
print.
Its head to it.
Yeah.
Fine.
Yeah, if it goes about a bad method, I think that implementing some kind of either screen method similar to what MakerBot did, or even removable build plates so that you would just bring a new plate in, set it down with an arm of some kind would be ideal.
And if you add enough.
Yeah.
Well, if you're doing the sushi conveyor idea,
Right.
you sit there and have the whole thing and it just goes da 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 da. The delta bot's perfect for that.
Exactly.
Because it's like you have the plate fairly level, and hey, who gives a shit, really?
Yeah.
Are we cussing on this?
Apparently.
Okay.
Well,
Screw the FCC.
Well, I have no plans.
well, you
on
can go
being
Grandpa
broadcast.
Munster on it and be like, F the FCC! But I don't think we're going to go quite that extreme just yet.
I do think the FCC is a little heavy-handed, but
I will agree that they are, but
that's
with
not the
any
argument
government
we have.
institution, it starts with the best intentions and goes haywire from there.
Isn't that any organization?
Well, yeah. That's weird. I mean, of course. So, does anybody any other comments or anything with that? Or any other ideas
Heated
for
blue platform? You were going to draw something earlier.
Yeah.
What were you going to draw?
Yeah, it was not that automated thing. It was way too complicated.
I think, though, if you did do it sushi style, that you would have issues trying to keep consistent heat levels.
No, you actually made the heater part of the individual.
You
slides.
have a heated room.
And actually, speaking of heated build platforms, we can kind of segue into something that Ryan is working on. Whether or not he wants to speak about it, it's up to him, because it's one of those things like, this could be really, really awesome if it works out. And I really
embarrassing if it doesn't.
even so, the concept of it, and even some of the stuff that I've thrown at you with it is pretty interesting.
Well, we still have to work out which one will be more effective, even after we do the prototype. But so, what the idea is we're going to use glass and then come up with I've come up with a toner transfer method that makes it really easy to throw toner onto metal, which that allows you to use a lot of electrolytic wet bath stuff that you wouldn't be able to use with just wax printing or wax transfer.
And since we're going to be putting this on YouTube, if you look right up in here, you'll see a link for his instructables on how he did this.
And then he's also got a blog, too.
Yep.
And
got a blog
so do you. You've got a
Yes,
blog, too.
I
so
do.
we'll get you that.
Yep,
I
we'll
am
talk about
currently
that here
unpublished.
we'll talk about that here in a couple minutes. But back to what Ryan was saying.
So anyway, so if you lay a sheet of copper onto the bottom of a piece of glass with epoxy, you can lay out and etch a resistance pattern into the glass, or into the copper on the glass. Then you use the clean side of the glass as a heated build platform that's directly heated.
Because there's very few things that are flatter than tin billet glass, which is pretty much everything that you're using nowadays.
Yeah.
So that's the idea. That's the hope. Scott suggests an idea that we should use conductive ink and an electrolytic method where we would possibly copper on traces.
Electroplated.
Yeah.
Electroplating.
It was one of the things I looked up with that too was a company that was selling an electroplating ink for art pieces.
Oh.
And so what they would actually do is you would have a sponge that would have your electrolytic material that was going to be transferred, and you would actually just go through with the sponge, and that would start your electroplating.
Huh.
But the thing with what you're talking about too, you don't need that much liquid because you're only submerging the underside, and you just need a large enough container. And we can even make something out of plexiglass using the laser cutter here in space.
Of course. Or the idea would be to spray it locally.
Yeah.
Moving on to actual producing.
Well, since it's ink, we can even do screen printing ink.
Have you seen the laser cut origami, where they use the heat of the laser and let it bend naturally?
Wow.
So you could use that and get all sorts of neat bent circuits.
Yeah. That would be interesting.
Did it work with, well, if I lay it onto...
A lot of it was they had the normal laser cutter. We've got a laser cutter in space, XY, nosy.
Built by hand.
Travis McGee, he's awesome.
Yes,
They had a laser cutter like that, and they just had a servo that would orientate the thing so it would bend.
Oh.
So you would sit there and heat it up just a little bit, and then the plastic would get hot and bend. So it was really cool.
Yeah.
So you use that with that, and then you make all sorts of cool things.
Yeah, it's just I gotta lay out the copper leaf on the plexi first.
Yes.
Okay.
Which,
Or later.
well, the other method too is that if we used, we also have a vinyl cutter in space, and I know that I've seen vinyl cutters used in the past with copper sheet.
Mm-hmm.
So if you get thin enough copper sheet and the adhesive on the backside of it is strong enough to take the heat, then in theory you can just cut it out using the vinyl cutter, and then you just recycle whatever your scrap was.
Right.
Because copper's cheap and all. But that's another way to do it because then you're just basically making a pattern that you stick on.
Just for pacing wise, it's been 13 minutes.
Wow, we're really chugging through stuff.
Yeah, no.
So yeah, I mean it's our first podcast, so we're still kind of experimenting with it all.
Just giving them a feel of time, because I know exactly how long it's taking and how you all are sounding on the microphone. You're all talking pretty loud.
Cool.
It's good.
So yeah. But yeah, I mean, are you really against electroplating, or do you think that's going to be a method that's not really going to work as well?
Well, it's just the idea I haven't worked out so far is that if you spray multiple things, because with all the stuff that's already been put out there, you've got my method and then a couple of other things, the spray booths. If I find it and put it in the description for this video's out, there's a guy who's done a really great build on spray etching PCBs. And it's kind of pricey and involved, but it ends up looking great, and has its own self-contained reservoir of water and etching. It's really awesome. But he's managed to get that down to about 2 minutes per board. A full-size board would be etched. So that's lends itself to me not having to work so hard making a dozen boards this time.
Yeah. But at the same time, if you're also going to be the only body producing any kind of build plates like these, then you can really set your price.
Oh yeah, but
set it reasonable, set it to.
Well, yeah.
I'd hope that people would like it enough, and even a dozen people, that would be a huge order if I was going to take a 30-minute.
Well, either that or if I buy one from you for the big machine.
Yeah.
That's
well,
only.
that's going to be a different story.
Yeah.
Probably custom make that one.
Yeah, and we'll cross that bridge when we come to it, because it's going to be like 5 feet square,
4.5.
It's a little bit bigger than 4.5 feet because 4.5 feet is just the nominal build volume.
Oh, God.
Because like the actual build volume is going to be slightly smaller than that, depending on how things work out.
It's probably going to be about 25 square
What about? Yeah, right there.
feet.
Yes.
Yeah, so that's going to be the whole spray bottle thing.
I will break you.
Nah.
I will break my back.
Peristaltic pump, continually pumping acid over it.
Oh, yeah. But if you're going to do something that size, you'd probably go into a bathtub and
You
Have
need something
a-
bigger than a bathtub. You need a kiddie pool.
maybe. kiddie pool.
That's what you'd
And
really
then you'd have a pump sprayer with foliage.
Peristaltic pump, you don't have to have any of the etch and touch, any of the mechanical parts, it just goes in the tube.
The pump sprayer can actually take hydrochloric.
You're sitting there and doing that? Yeah.
Yeah.
I mean, you can sit there and do it automated, and that's what I like.
But
And we can make it with the laser cutter, we can make it with the printer, we can make it by hand with wood.
Yeah.
Peristaltic pump,
oh,
it's easy as shit.
we had a few because we've taken apart God knows how many printers.
Yeah,
Brian, you got anything project-wise going?
getting a new extruder hopefully Friday,
Excellent.
so I can start getting my machine going again.
What version of RecRec do you have sitting on
Person from Maker Gear.
there? Gotcha.
Yeah, and one of the things that Bass here and I do, we
Yeah, I got to call you Bass now, right?
Seabass here and I, kidding. One of the things that we do is we help to host a 3D printer meetup here in St. Louis. Yes, we are based out of St. Louis, by the way. One of the things that we do is we help to host a 3D printer meetup here in St. Louis once a month. It's pretty much when we're able to schedule it in the space and we have time between our jobs to actually help to host it. And we've actually gotten a ton of people in the St. Louis area who are interested in coming in. Last time, I think we had 6 different types of printers here.
6 different type of printers. I think we had 26 people in the space.
And it was 6 different
That's
types
a
that are
lot.
running,
Yeah.
not including the other 3 that are sitting on the side wall here.
That are broken.
Yeah, that are in various states of functioning. I think that's the nicer way to put it.
Broken.
One of the things that I know I'm also working on that I'm hoping to actually have running. Our next meetup is this coming Friday, right before Halloween. And one of the things that I'm hoping to get running is this piece that I have sitting over here that Ryan's going to be gracious enough to grab for me. And that is my filament extruder. With making a giant 3D printer, I needed a cheaper way of getting filament. And this thing is not that light. So this is my little variant on the Lyman and all that fun stuff.
Lyman, Philibot, all
Yeah.
based from the same design.
We weren't really planning on talking about this one, but we're really kind of moving through a lot of topics today. Probably for the next couple podcasts, we'll narrow it down a little bit. But for today, this is the one that we're looking at. And this guy's actually, it ran me around $200 to $230 to build it, and I combined the plans from a guy named Bob Teeter. I think it's Teeter Consulting is his website, and another set of plans from the version 2 of the Lyman. Between those two, like the Teeter one is actually a variant of the Lyman, but he did some things a little bit different. So we actually had one of our machinist friends. He took care of getting this section here cut, and Tom, he's a great guy. And that's apart from the Lyman. Several parts here are from the Lyman. The band heater that I have down here is one from that Teeter used, and it's a bit different specification-wise from the one that the Lyman used. Other than that, it's pretty simple. It's got a pre-geared motor that's all DC. It's run from a PWM up here that goes to 11 instead of 10.
Always have to make it go to 11.
Yeah, 11 is much better than going to 10. Aside from that, it's got a little pillow block here that helps to hold it, and that pillow block helps to hold the auger bit that runs the length of the machine. We're still, Ryan Bass here has actually been gracious enough to be helping me out with it. But we have a little bit of filament that is print worthy. I need to finish working on the hopper that's actually going to sit in it, and from there it's just going to be the hot end down here has to get wrapped so that it has a little bit better heat retention. Because right now, when you have somebody walk by it, it's going to cause the heat to vary on the PID.
And the PID's got actually got a neat little auto-tune feature, so once you get tuned in, you're good.
Yep. So, yeah, that's this little guy. And for anybody who's wondering, this white piece here in the center, that's actually my thermal insulator. What was that material?
It's a block of Teflon.
Yeah, it's a block of Teflon.
Someone got for $1.
Yeah. So one of the local
There's
scrapyards
3
has
feet of it left.
one of the local scrapyards has some plastic, and
Scrap everything.
yeah, they're crazy. It's all family owned and run. It's good old Shapiro's.
Nice thing about an old manufacturing town is you end up with everything.
Yeah.
Well, you've got Boeing, you've got Monsanto, you've
Yeah.
got broken down pork slaughterhouses.
Yeah,
Yeah,
and every other machining shop that's going under too.
I mean, they have stuff that you would not believe. I've seen bearings bigger than my head that are they're still sealed and work perfectly.
Yeah.
And they're like, oh yeah, we'll name you a price on that, and that's how those guys operate.
They'll sell it by weight rather than function.
Because they don't really care if it functions or not as long as you have cash.
Yeah.
So that's this
You
little
can deal
project.
with cash, and for people and friends.
Yeah.
So yeah. And that whole rig runs on a 12-volt power supply, and I just picked that up real cheap on eBay. I'm still working on getting a blog post together about that guy, and once I do, I'll have a current bill of materials so that I can just show folks what exactly
That's plugged into that.
is all involved in it. So
I know, I'm just trying to keep it out of the whole shot so they can see Scott without it on tape.
Hey,
Tape it where?
to the table,
Mhm.
not under the table, to the table, so it doesn't move. Sorry, I'm a little bit of an asshole.
Only when you're drinking.
I sips.
So yeah, so that's this guy here, and part of the concept behind that was if I'm going to have a giant 3D printer, I'm going to need something that's going to be able to produce enough material to lower my costs. So I actually found a local St. Louis-based company that will sell me PLA, ABS, whatever kind of pellets I want for fairly cheap. And those guys are great. I've been working with them a bit. Right now I've got PLA pellets. And the stuff that's coming out has been really nice once I finally got the machine tuned in.
And the supplier for all the pellets are NatureWorks, right?
It's a NatureWorks product, and the distributor is Jamplast.
So NatureWorks was, if you got filament before like 2010, it was NatureWorks filament, which is awesome stuff. I still have it and I love using it.
Yep.
But they stopped making filament on small batches for a while. I don't know if they're back up, but it's a good product.
And I know Jamplast has even told me in the past, like, if you need a way to turn this into filament, just let us know. We'll figure out something, or we'll hook you up with somebody who can do it. So you're buying the pellets and they're making the filament for you. Which, it's a great idea, and I'm not against that yet. But with doing something like this, I can do it all in-house. If one of the members from the hackerspace wants to buy a batch of PLA off of me, I'll churn them out a bunch of filament at cost.
You sell them the pellets and they do the film for themselves with your supervision.
Exactly. Do it like that too. So I mean, plenty of stuff in the works.
Yep.
But yeah, that's that little beast. One of the things that we're going to try and touch on tonight as well is the Peachy printer. The Peachy printer is just a crazy cool little concept that I have to look up how much money they have made because it is just ungodly awesome. But Ryan, you want to explain that a little bit, or what do you guys?
I don't know much about the Peachy printer. I've been focusing on other things.
Okay.
Well, this is the first I've heard of it. So.
Peachy printer is the world's first $100 3D printer. And it's really cool. It uses a laser that runs into a resin bath, and that resin bath sits actually on top of salt water. So it gets rid of the mechanics of having to raise and lower either your laser or your platform containing all of the resin. So by adding more salt water, it makes the build actually move up.
So this is a Kickstarter?
It's a Kickstarter campaign. I just looked up how much they made.
Is it done?
It is done.
How much done?
Really done.
No, I mean like time wise. You can always have more money.
Yeah. They finished up on October 20th. Their goal was $50,000, and they raised $651,000.
They really got everyone who wants 3D printers like, oh, $100, I can do that.
Yeah, exactly.
But I think people are going to be disappointed by the size of the build platform.
Well, and
I
they
don't
even
know.
say that it's a very small size, and it was kind of hacked together in a hackerspace.
Like this one.
Yeah, similar to this one. The difference is, though, that it uses the audio jacks from your computer to communicate with the machine. So it uses the audio send to send information to the printer itself, telling the laser and the reflector how to move. And then it gets feedback information from the microphone jack. And the reason for that is because they say that the audio jack can process in 32-bit already, so then you're processing a much higher quality and much more information faster.
So it beats out a parallel port by landslide.
Well, yeah, parallel ports are kind of junk nowadays anyway.
There's still people are still using them all of this.
Well, yeah, there's a lot of really nice old school machines that still use them.
But that's the part that I really like is that it can use a sound card.
And all the software side stuff is run through Blender. So it's all programmed in Blender, and that's one of the things that they're going to use the Kickstarter money for is improving their code. So their quality isn't the greatest in the prints that they've shown.
Yeah.
And I'm sure that even then it's still like the best of the best prints.
I think now that you've mentioned it, I remember seeing this one.
But even with that, once they improve their code, those prints will improve tremendously. And I think that's going to be one of the real interesting things to see is how those prints improve once the code improves.
Well, they even have some mechanical things they could do.
Well, and that's one of the things they're actually trying to shy away from. There's another version of the Peachy that's already come on the market, and that one is basically a mechanical variant of it. And it's a couple $100 more, but it has a lot of the same principles and ideas. So it's basically the knockoff version of it that's higher priced.
That doesn't make any sense.
Well, because they have it on the market now
Oh.
instead of a Kickstarter where it gets.
So does a major mechanical advantage of it? Does it move the laser?
It's I'd have to look it up because this is one of those things that I just kind of remember spur of the moment. But
Ooh, interesting searching.
yeah. But I mean, it's a stereolithography machine already.
Right.
The other version of it.
I've heard about it. I don't know what it actually is. I know that they did have some mechanical upgrades, but it's not the mechanics which are the amazing part of it. It's how simple it is.
Yeah, and that's the whole idea. Like, it uses a drip feed to increase the resin height.
Right.
So then that drip feed, it drips onto two connectors. So then when it completes the circuit, it sends a signal back saying, hey, the circuit was just completed. I just added one drop of salt water to the rest of the reservoir, and now it has raised this many micrometers.
Right.
And so the guy figured out how many single drips coming out of that tube is equivalent to a certain movement height. And so by increasing the drip flow, you can actually increase how quickly you print.
Right.
And that'll then in exchange that'll change your layer height.
Right.
So
It's okay.
it's ridiculously simple and really, really interesting.
Yeah, now that you talk about it more, I remember seeing video of it working. A lot of the biggest problem mechanically that I saw of the whole thing was how the water would actually stick to the side of the drip tube. That would probably screw with the resolution.
It's never wet.
Is that?
It's never wet.
That's what I was thinking.
Or Teflon or any other hydrophobic surface.
And that's the only mechanical thing I would say that improve everything.
Yeah, and one of the other things that they talk about the Peachy is that it also does scanning as well.
Oh, they got galvos.
Hmm.
It does lasers by galvos, which
Okay.
is a laser control mechanism.
Yeah.
If you've seen a laser light show, that's what they used to move it.
Okay. But yeah, it's really interesting too because they're talking about doing 3D scanning as well as 3D printing for just $100.
That's actually really impressive.
Yeah. So that was one of the things that's really interesting about the Peachy itself. And one of the reasons that we want to talk about that today as well is because it's something that's still fairly fresh in a lot of tech people's minds, and there's a lot of really interesting buzz that's going around about it. The Kickstarter may have ended a couple days ago, but still, it's damn impressive to see something this new and this creative and things like that just really blowing everything out of the water.
I really want to get some cast AR glasses. It's like I can't
Yeah.
do $400 right. I could do it, but I don't want to do it.
Um,
Kickstarter's bad.
Couldn't justify
well,
it, right?
that's another good thing that we can kind of segue to then. Since we're talking about new and emerging technology, what's up with the cast AR stuff?
Jerry Ellsworth, the hacker guru of fame, she's making a AR. What?
Well deserved.
Yeah. There's a really, really good story. Look it up. You'll probably find it. It's probably on her YouTube page where she talks about where she came from. She started at rally cars, ended up at augmented reality glasses currently. She'll probably do something again in like 2 years.
That's a heck of a segue.
But right now, the cast AR glasses are glasses you put on. They have 2 projectors above your eyes, and you look at a retroreflective plate or sheet, and it bounces the light from the projectors to your eyes, and then use shutter shades to improve the 3D effect. Because you already have 2 projectors, so you do get some 3D, but with the shutter shades, you get real 3D because you're separating the eyes. And she's made an ASIC chip communicates with a camera to do positional tracking. And it's just those little tweaks that she's done. She's planning to get the whole chip down to, or the whole thing down to 1 chip. So it's going to be low power, high speed, high performance, and cheap. Really, really cheap. Like, it's $400 for glasses, the controller, and the RFID plate, and probably a sheet of the retroreflective stuff. But that's not too bad. If you look at the Oculus Rift, you just get the Oculus Rift. With the Cast AR, you get AR glasses, and you get VR glasses, and AR stands for augmented reality, VR virtual reality. So,
and one of the interesting things that one of the articles I've seen, they've actually got people playing tabletop games, so miniature games, and it's projected on top of a basically blanket, and that blanket has an RFID reader embedded underneath of it, correct?
Yeah, that's the
Yeah.
and that's what you get for $400, and then you get an RFID tag, and they've got in the video that you've seen, they've got a printed wall, like a 3D printed wall with an RFID tag in it, and then they sit there and they build it like block by block. It's really cool.
So I mean, that could really be something that can for some of the more higher end game shops or even hackerspaces to either invest in or hack their own version of it.
Oh, yeah,
And
it's
you
not that expensive either.
no, and that actually be a great way too. Like I always think on bringing new people in, that could be a great way to bring people in, but then also to showcase the technology. And I'm always about showing folks like, hey, this is out there. There's stuff for you to learn about. Like it's not terribly challenging, but there's a bit of a learning curve with
No,
it.
the other collaborator, who I'm blanking on his name, he's focusing on ease of access to coding for it. Like, he's just making it as easy as possible as you can to add like a module to your game, and boom, it works.
I know you said Ellsworth. One of the other things that she did, she worked for Valve for quite a while.
Yeah, she developed the thing at Valve, and the sad story is when she got fired, she was like, well, I worked so hard on this thing, and Gabe just said, give it to him. And the lawyer kind of gawked at him and was like, give it to him. We're not going to use it. So Valve is an awesome company.
It wasn't so much of the firing as it going in a different direction.
Well, yeah, they weren't doing the same thing. They want to do Oculus stuff rather than AR. Like they're doing hardcore gaming hardware. So, they're focusing on computers. They're not focusing on the real world.
Well, now they're focusing on linear television as well.
Well, yeah, but no, it's still a computer. It's a desktop.
Yeah, and especially with all the stuff that Valve has at people's disposal, it only makes more sense that you're going to go towards that market that you're getting the bulk of your paycheck.
They're already giving you money. They're going to give you more money.
Yeah. It's like
altruism is one of the greatest marketing strategies.
It's a good sign. Because they wasted the money. They've wasted the money already. At least they're going to get something useful out there.
Yeah.
Well, I also like the glasses because, hey, you buy a $200 pair of glasses, you pair with my phone, and we can look at the same image and work on it, or you can use your own phone on the same platform,
And it still shows up.
and it still shows your stuff to you and my stuff to me.
Hmm.
So it's like you can share the screens. That'd be so awesome at work.
Wouldn't
So you have the monitors, and you just look up, and it's like, oh, that's what's happening.
We both work at the same IT joint.
Yeah.
Yeah. I'm not an IT guy. And
You're trying.
I'm trying, but I keep finding myself like I like to do manual labor things.
Yeah.
Because that's what I've done for a long
We're
time.
trying to do things too off the side. Everyone is.
But that's another topic for once we got a lot of stuff hammered out.
Yeah.
Right now it's currently all hobbyist stuff. Really.
Yeah, but we'll keep that
Prosumer.
we'll keep that on the cuff for now. So let's see here. One of the things that is going to be rather interesting that I really need to do more research into is the SLS patent expiration stuff.
Yes, that's gonna be fun.
Yeah, so one of the things that's going to be happening here in early 2014 and kind of progressing is that SLS 3D printers, the patents on them are going to be expiring, which means that you don't necessarily have to pay license fees to use a lot of the concepts and mechanics that are within the patents.
And SLS stands for Selective Laser Sintering.
The way that kind of works is if you look at the Shapeways version of it, you'll have a powdered material, whether it's nylon, ABS, PLA, so on and so forth, that's in a hard vacuum chamber, similar to like a pressure cooker, just in reverse.
It can be. It depends.
But part of the reason for that is so that the material will compress because it doesn't have oxygen and other gases keeping the layers and the material separated from
It's
itself.
easier to control static, you get compression, and you don't lose any heat.
Then that chamber is then heated. So then you're bringing the material up to a temperature where it's just a few, maybe 10 degrees below its melting point. So it's still in a solid state, and the laser will come through and it'll knock it over to a meltable point and cause the material to fuse to itself. Then another layer of material is brought across at a certain layer height, whether it's whatever layer height is specified by.
It's actually fairly tiny too.
Yeah,
It's not-
It's usually limited only by grain size.
Yeah, it's like 0.0 whatever, depending on, like you said, like grain size. That material will come over, laser will come across, run another pattern, and hey, you got another part.
Yep.
One of the really cool things with laser sintering, though, is that you can not only make very high detailed things, but you can also make moving parts very, very easily. So like if you look at the Theo Jensen Strand Beast, where it's these little skittering legs, and he's got a formula for the distances between each part. If you look at something like that, you can print a Theo Jensen walker. Feel free to look those up. Theo Jensen walker. But you can print one of those very, very easily, and as soon as it comes out of that powdered material, you run a little bit of air across it, knock the powder out, and it will move. So then you're set to attach a motor directly to it, and you can go. So that's the really cool thing with that. It's also that you can print in a wider array of materials, but then you can also print in some powdered metal materials. One of the
a little bit more power.
Yeah, that takes a lot more power. One of the examples that I tell folks with that who are really new to all this is in Germany there was a woman who had bone cancer in her jaw.
Oh, yeah.
They did a 3D scan. I can't remember if it was a CAT scan or an MRI or a PET scan, whichever one it was. But they did the scan of her jawline, and then they had that printed in titanium. That titanium was then coated in ceramic, and your body will recognize ceramic as dead bone, and it will recalcify it. So your body basically starts to reclaim that, recalcifies it, recognizes bone. So they basically cut her jawline between the mandibles, and then removed that, put the new part in, and then within about 2 days, she was eating solid food.
Yeah.
So it's remarkable what you can do with these SLS machines. Because, I mean, we use what are called FDM machines primarily, and that's filament deposition machines, which means that a hot glue gun and a plotter had a bastard child, and that was a 3D printer. And that's really the best way to put it.
Yeah.
So the processes themselves are quite different, but the end result is similar. It's just the level of quality and what you can actually produce with them. That's the biggest thing. So like with an FDM machine, to do the same Theo Jensen Walker, you would have to have a second material that was dissolvable or could break away within those tolerances. But
We're getting there too, though.
yeah, we're getting there as well. Like the mechanical, that's a great segue. In talking about doing multiple materials, you'd have to have something similar to the mechanical hot end that was on Kickstarter a little bit ago. So by having something that can do multiple materials all at once, you're able to produce those really intricate parts that require multiple materials, require things to dissolve out, and require much larger support to get either larger overhangs or to do things that are just like floating out in space that have to connect eventually. So that's one of the things to do with that. And like with mechanical extrusion system, I'm right. Feel free to chime in.
I'm laughing at Audacity.
Okay. With mechanical extrusion system. Yeah, with the mechanical extrusion system though, that was one that was really cool. Because that was on Kickstarter not too long ago, and unfortunately,
That was the one that was a dual extrusion, right?
Oh, they didn't make money.
no, they didn't. But they actually got up to quad extrusion.
They did.
Yeah, they had 4 extruders all running at once.
Because you can mount them facing.
Oh,
Yeah.
no, okay, so that makes sense.
And the cool part with that,
So did they use a ratcheting mechanism in there, or do you know how they did that?
I haven't taken a look at it.
I'm pulling it up now actually.
Um,
But the way it actually worked was you have a single motor. So if you want to get an example of this,
I remember I mentioned this at some point at one of the 3D printer meetings.
Yeah. The way that it works though, if any of their pictures ever load,
Yay, internet.
here it is. So that my associate here can understand what I'm talking about. You have a single motor, and then you have a servo that will control.
I thought they got it to purely mechanical, where they didn't even have a servo anymore.
No, it had to have a servo because they didn't have a servo at first, and they were just trying to do it all mechanical. But the problem was that they weren't able to move everything as they needed. So just by having a little servo that would kick the gears over so that everything would lock in. So it's 2 separate gears and a main drive gear, and it will essentially swing one of the gears in to be driven to push the filament.
Makes a lot of sense.
Yeah, and by doing that, you're lowering a lot of mechanical issues that you would normally have.
You're compressing it a lot.
You're adding more compression to it, but then you're eliminating some of your momentum and weight issues that you would have from doing a direct drive filament system.
It's still direct drive. It's just a huge ass geared stepper motor.
Exactly. So,
Just like the ones you usually use, right?
Yeah, I've got a direct drive in mind, but it's geared up.
and that's what I'm getting at though, is that you lower your weight because you're only using one motor with a little bit, like a couple ounces more for all the mechanical parts. Whereas trying to use 2 motors is going to add a lot of momentum, which means you have to slow down to account for that. So this will essentially allow you to speed everything up.
Yeah. No, there's been a lot of work on the kinematics printing.
Yeah.
Like the Tiny G.
Tiny G is amazing. I have to admit that.
So what is the Tiny G?
What is the Tiny G? I thought you'd never ask.
Well, they can, so I had to.
Somebody has to. Tiny G board is a motor controller board, and it's one of the ones that I've been kind of like oohing and awing and drooling over for a little while.
Lots of drooling.
Yeah, lots of drooling. There have been issues and slippage. So what the Tiny G is, it's a motor controller board, but it has some amazing feedback control. So Cynthios, the company that is producing it, it's just a group of hackers that have been working on it in their spare time, and the results that they're getting are just awesome. I got to see it when I was at the World Maker Fair, and they had basically a plumb bob that was a several pound plumb bob, and it was attached to an arm. That arm was then in a track and running back and forth along that track. Track was about 4 feet long. And as it would move very quickly across this track, the plumb bob would swing out and ride with it, but then their motor control was fine enough that they could actually account for that, and the plumb bob would stop dead. And that was really cool to see it do something like that, and to be able to have enough control to do that. And in talking to them and a couple of the other companies, there's a wire bending company. And one of
Do you have wire?
I think that's who it is.
Because those are the big guys, and big names in open source data wire.
Yeah.
Yeah.
They're kind of the only name.
Pretty much. I mean, I
but,
can't imagine what kind of need they would have had to make. I'm going to make a wire machine.
There's a lot of good things.
Yeah, and some of the stuff that they're producing is actually pretty cool. If you think about it, you could make sunglasses like that fairly easily.
I mean, I just wonder, is like, what spring can't you find that?
Well, they're not doing springs. They're doing.
It's all basically flat, and the way that it works is as the wire is extruded, it will bend it and continue to extrude it.
Well, I've looked into that.
Yeah.
I mean, it's just kind of what brought it on.
Like, I know
Interesting.
John and I were talking about Spider Jerusalem from Transmetropolitan.
John is another member of the R Tractor, currently president of Hackerspace.
And a pair of Spider Jerusalem glasses cost like $400.
But they're mostly bent wire.
Yeah, they're either spent wire with 2 different size lenses and colors.
Ah, there you go.
It's not too hard with that. It'd just be, you wouldn't even have to think, it'd just be done.
Right. Yeah.
I remember looking at that thing and was like, rollers need to be-
So, I mean, and that was one of the things that I'd asked those guys about, because they were using the Tiny G board. And
Oh, they were?
They were.
Awesome.
And they had they had a double stack stepper motor that was controlling the bulk of everything.
Okay.
And I had asked them about running some of the heavier duty steppers just with the stock drivers, because everything's embedded. It's not like the plow loop drivers that you normally have on a lot of the 3D stuff, where it's just drivers that are inserted, and if one burns out, you can just swap it out. Well, actually, with theirs, they have thermal controls built into the programming, so that if it reads that your stepper driver is about to blow or it's going to overheat, it just shuts it down.
Does it shut everything down or just that one?
It shuts that one down.
Ooh, that could be fun.
Yeah. So, but I'm sure that in shutting that one down, it'll cause everything to stall out, and it'll say, okay, we have to stop everything because we're.
It'll probably trigger something like an end stop where
Yeah,
it just
exactly.
stops.
It'll probably stop everything dead so that you don't have anything blow.
Right.
Which is great because I've built a couple of boards, motor controller boards.
No, we've all probably destroyed about 3 or 4.
Yeah.
Yeah.
Well, I had to, as a part of the Fab Academy, my final project was doing a CNC machine. So I designed one out and I made a Gerbil shield, and I blew up a couple of stepper drivers. And, the magic smoke, once it escapes, you can't bring it back, no matter how hard you try. So after doing that, I realized how important that kind of stuff is. But yeah.
Speaking of Maker Fair,
Yes.
anything else interesting out there? So I did hear of a metal printer.
Yes.
I'm incredibly interested in metal printers.
Yes. Vader. Those guys were actually really nice. It's a father and son team, I believe. And I think they have a couple other guys that are working with them as well. They came over and talked to me at my booth a bit while I was setting up for Maker Fair. Yeah, those guys were really nice. They had a lot of great input as well. I haven't actually had a chance to see how their machine works.
I heard they hadn't gotten it up and running yet.
From what I understand, they still have the prototypes. They have the prototype up and running, but it's still just that prototype machine, and they're working on getting to a point where their first production model is going to be like $100,000 and something.
Wow.
But it's a full.
Actually the size. That's actually a cost of a fairly decent EDM machine.
It is, but you can't do metal with an FDM machine.
EDM.
EDM.
Electron beam.
Oh, okay. Yeah.
Arkham.com, excellent site. That's what I watch and drill over.
Yeah. Actually, what was the one that what's his name? Terrence was talking about that the Hackerspace managed to get from DARPA.
Oh, I don't know. No, I don't remember what that one is. I know what you're talking about though.
Yeah.
Terrence's Open Beam.
Yeah.
We had Kickstarters.
Yeah, we had a gentleman who came through probably about 2 weeks ago, maybe a little bit less, from Open Beam, and it is Terrence Tam. This guy is actually really cool. He came through, donated a couple of kits, and we produced this little dangerous thing.
Is it in camera?
That's not dangerous.
Turn it just a bit. There you go. So, yeah, what it is, we basically turned it into a little ballista, or more like a crossbow at this point.
Yeah, that's the third iteration of something like that. I started the catapult, and then Chris made a better catapult, and then you guys pretty much made the crossbow.
Yeah.
It's falling apart now.
It's
So yeah.
Alright.
But
It shoots glue sticks very well.
yes, it
we
does.
had those sticks in the locker.
Could probably shoot glow sticks too. Stick that in there with that. And see
Well, that's one of the things that I guess we'll have to try is shooting some glow sticks. Shoot the techno.
I would rather get a pneumatic cannon.
I'd rather make the disc shooting gun.
If I need those.
Need all of them.
One of the things that we have is one of our members donates a lot of old and used hard
Are you
drives.
kidding? Everybody donates old games hard drives.
So we have a ton of used hard drives that have been pulled apart.
They're like printers. They keep multiplying.
No, they're more like tribbles. They keep multiplying.
That too.
Except
they actually use these.
So we have these couple piles of things, and they are hard drive platters. One of the things that I want to do with them is make a disc gun that shoots hard drive platters. And just because I think that would be freaking awesome. I don't know why, I just do.
That's one of the first things I did when it came to the space.
I made a thrower, but it's not a gun.
That was a gun.
It was like an atla.
Yeah, that's true.
An Atlatl?
Yeah,
You'll probably have to look that up to figure out how to actually pronounce it.
Or
I do
highline scoop.
Right.
Yeah. But yeah, as you can see, there are quite a few things that are going on with just the three of us, but there's also some of the stuff that you can kind of see over here.
That's a robot.
Yeah, this guy with the green shirt on here is actually a telepresence machine that Hackerspace has taken to a couple of maker fairs. And it's a really cool thing. They actually used Google Hangout to...
Royal we of the Hackerspace.
Yes, the Royal we. Not to be confused with the French oui oui, but
Since was asked if we could use yes instead of oui.
yes. But it's used as a telepresence machine, and it worked really well when they took it to the Kansas City Maker Fair. It was a huge hit. A lot of people really liked it.
Couldn't hear a thing.
Yeah.
Couldn't hear much from the Hangout side because it was just very, very loud.
Random people's faces getting really close to the camera.
What's going on?
Like, oh, okay. This is kind of fun.
It was a little awkward, but since then it's been refined quite a bit. George, the member who has been working on that.
And it's basically the go-to robotics guy lately.
Yeah, he's been great with a lot of that stuff. Originally, it actually had a paint gun on it, and it was able to shoot.
That's still the plan, I think.
So, and it's a self-defense thing. That's what we're going to call it.
Right.
Well, originally it was going to be a boxing robot.
Yeah.
But that got canceled.
Yeah. And that was something
Why?
that was something that was going to be run through Zombie Squad.
Zombie Squad and the Burlesque Girls. I can't remember which Burlesque crew.
Zombie Squad is a survivalist-oriented group that focuses on being prepared to survive the zombie apocalypse. Which actually, they through that theme they do a lot of first aid training and survivalist preparedness.
If you heard the last lecture, the whole head fake concept, it's that to the extreme.
So one of the things that they'll do in using that, the idea of zombie apocalypse, they'll actually go around and they help to sponsor blood drives and do disaster preparedness for people, especially in this area since we are a part of Tornado Alley and we do have floods and things like that.
It was started in St. Louis, but now it's
Yep.
all over the country and probably all over the world.
So it's one of those things, it's one of our claim to fame.
If you don't want to join a hackerspace, check out Zombie Squad.
So
Zombie
that's,
Squad, Panera, and what else? Panera. Well, here at St. Louis Bread Company.
Oh,
Yes.
you're talking about it's all switched over to Panera. The company, I think they got bought out.
They did? Yeah.
We're currently at 55. Just by the way.
okay, that's what I was wondering. So, well, you guys want to say goodnight then, since we're getting pretty close to an hour, and we'll keep it just under?
Sure, yeah, we'll do an hour. That probably people had enough. They've probably already stopped listening. If you have anything to say, please say it.
Yeah. Feel free to leave comments below. We
Useful
do.
comments, please.
If you guys have suggestions on things you'd like us to talk about, or if you would like us to see, if you'd like to see more of us and bring the camera closer, or if there were things you couldn't hear, anything like that, feedback, suggestions, we will try and read the comments as best we can. We do not tolerate trolls. You will be banned as best as we can, anyway.
It's fun for us.
Banned, deleted.
Yeah,
Blocked. It's not worth our time. Not worth anyone else's time.
exactly.
Yeah, we have plans for the future for this thing.
Yep.
Get a digital recorder with 4 channels. Maybe get a different camera set up with actual cameras. Like right now, I'm running off a program I found an hour ago, and
Hey, open source.
ran it.
So if you keep up with us, you will see some improvements to more podcasts that we do. Each week, we're hoping to be a little bit better off than the previous.
We each
And-
have different things we're working on that will have announcements that are kind of cool.
Hopefully.
Yeah, and once we do hopefully get another camera or maybe 2, we'll even be able to do some close-ups on some of the stuff that we've created, or even try and give folks a little tour around the space.
We may need a 4th person.
Yeah.
There's an empty spot.
Awesome.
Yes,
And that spot is for anybody who comes in of note.
yes.
Yeah, no. We'll,
And since we are broadcasting out of a hackerspace, which is open to the public, and if folks want to come through, who knows who may come through.
we've had Mitch Altman, Jimmy, not Jimmy Page. Crap, I'm sorry, Jimmy. I forgot your last name. He did the Lowell Shield. We've had That's What I Was Worrying About.
Yeah.
I
I haven't bet if that's what I was worrying about. What was the other one?
not
I did not know.
Caleb from Hackaday,
Yep.
along with Hackaday. The guy who did Open Beam.
Yep, Terrence Tam.
Bunch of cool people.
Yeah.
Join your local hackerspace. It's probably the best thing that you can do for yourself.
Yep, Sport Hacker
others.
Radio.
Support Hacker
Yeah,
Radio.
we're gonna try to get this on Hacker Radio. It's a Noise Bridge project.
Yep.
Noise Bridge is one of the oldest spaces, one of the more well-known spaces in the United States.
One of the
possibly
oldest
world.
established
Well, in the States, I don't know if it's the oldest established.
in the States.
Yeah.
I don't know. That I don't want to get into politics of that.
Yeah.
They're more of the well-known ones. They've got Mitch Altman and all those guys. That's
Yep.
why they came in. But yeah, cool things.
Yep.
Anything else?
No, I'm good. I'm Scott Rocca.
I'm Ryan Williams.
And apparently I'm Basilisk.
Yep. Thank you very much for watching, and join us next time.